Okay, I think we're ready to get started. So everyone who has already joined us, thank you and welcome to the Accelerating Kubernetes Intelligence webinar by Komodor. This session is recorded and the deck and the recording will be sent out to all of the registrants. We'll have some time at the end for Q&A, but if you have any questions throughout the session, feel free to drop them in the chat and we'll try to answer them as we go along. So today we have two very special guests leading this webinar. Both are from Cisco. Cisco is Komodor, one of Komodor's enterprise customer, and they are leveraging Klaudia, our AI SRE platform, within their CAIPE platform. So to discuss Cisco's Agentic AI and platform engineering journey, we have with us Hasith, who is a CISO and Director of Platform Engineering, and Arthur, who is an Agentic AI Engineer. And before we dive in, do you want to tell us a bit more about yourself and what you're doing specifically at Cisco?
Yeah, hi, nice to meet everybody. And so my name is Hasith, and I lead platform engineering and security functions for Cisco's accelerator called Outshift. And Arthur, do you want to introduce yourself?
Yeah, sure. Hi, I'm Arthur. I've been at Outshift, for around a year and a half, and my main focus is agentic systems. So on the initial version of Jarvis, and as we evolve that into CAIPE, yeah.
All right. So Hasith will take us through Cisco's journey from the very idea of why they even went on this adventure throughout the various stages of testing, evaluation, implementation, and most importantly, the outcomes and impact that the CAIPE platform had. So Hasith, do you want to start?
Yeah, and feel free to ask questions. If it is appropriate, I'll take them as we go. So first of all, what is Outshift? Let me start with that. So we are Cisco's incubation engine. So we very much look at what's coming up in the future. So 2 to 5 years out, and then look at how to incorporate those technologies into various products and strategy at Cisco. The current two areas that we have been involved in is one is quantum. So there's various activities happening in quantum space. You may have heard about Cisco doing this quantum entanglement chip. So that's prototyped in our wider team. And then Agentic AI, we have been doing various things in Agentic AI for the last 2 years, including release of open source efforts to sort of help how the future Internet of agents collaborating will happen and to facilitate that. Now, before I talk about more details, this is a very high-level overview of what platform, the underlying SaaS platform that's powering our cloud delivery looks like at Cisco for the incubation unit. We have AWS as a it's a single cloud provider strategy for speed at the incubator. So we are using a lot of cloud services there. Then we have a edge compute strategy for when you have specialized compute workloads or data concerns. So things like GPUs or quantum processing units, or if you have data that is stored, you have a edge play there. In all of that, there's a lot of Kubernetes clusters in play in AWS in the form of EKS, and on the edge, we run micro-K8s variants. And then in a similar notion, you have control components, so things like GitHub and GitHub Actions. We have a sort of a control and administration account with various functionality like Argo CD, Backstage, and then some things around active security, vulnerability scanning. Splunk we use for all of our logs and telemetry. Then we have third-party SaaS functions currently at a high level. So we're using Lightning AI for a lot of MLOps side of work, so model training and whatnot. And then Komodor comes in for simplifying Kubernetes and kind of making it easier to consume across the board. So that's what it looks like at a high level. I'm sure if you guys have very similar platform variants as how cloud native world has expanded. Now let's think about the whole platform and platform engineering and where we have ended up with. So if we go back in time a little bit, we obviously had a split in Dev and Ops. Then you had DevOps, SRE being very popular. You had containers, Docker, Kubernetes, cloud native, everything, exploding with a lot of possibilities and a lot of diversity in the open source space. Along with application architecture that evolved, so things like from monolith architecture into microservices, things being quite complex very easily. So when you look at a modern application stack, it's pretty complicated, and this is why and pretty complicated, and you have people doing things in lots of different ways. So this is why we have platform engineering as a discipline that's been introduced to streamline this function, which is a bottleneck by design. And it's not a bad thing necessarily, but because it's a bottleneck, it's always challenging to make sure that it's working as effectively as possible. And then we are scaling this with humans at the end of the day, meaning platform engineers, SREs, etc. Now, the important thing is, like, when this is not functioning well, you're going to end up with slow releases, a lot of frustration, burnout, particularly when it comes to platform teams. So AI and other changes that's happening can really help make this model scale further, because otherwise today it's very difficult to do it. And that's why whilst lots of teams and enterprises are adopting platform engineering, it's difficult to be successful in this. So this is our story in the last 2 years or so. I started in this role in January. So what I was stepping into was a somewhat burnt out SRE team because things are being pulled in lots of different directions. We did instill a lot of good platform engineering, but what was realized was, for a small team like us to scale with the complexity of the modern application stack and all the wonderful things that we want to do at the incubator, it's not going to be enough in terms of manpower. So this is where we were very much thinking how to apply AI, and because of the agentic focus as well on the side. So this wasn't a kind of a top-down project. It was very much a grassroots project driven by our needs and to do things better. So we started this project called Jarvis internally. And a fun fact there, I mean, it was literally, in our heads back then, it was very much like, hey, can we do platform engineering like Tony Stark was building the suit in Iron Man 1. So that was like the very quick one-liner vision back then. We started very small. So Arthur was doing some exploration work. We had a couple of internships. And then we when we had to change the workflow engine, we used LangGraph. Then we kind of, combined all of this and created a multi-agent system towards the end of 2024, which was very successful. And obviously, a lot happened beginning of this year. So things like MCP exploding. We have Agency Collective, which is our own work around Internet of Agents that has been open sourced under the Linux Foundation. A2A from Google. So we decided to make this a community-driven initiative under this group that we joined called Cloud Native Operational Excellence, around forming a special interest group around this. And then around July this year, we open sourced this effort as CAIPE, pronounced as Cape of a Superhero, standing for Community AI Platform Engineering. Now, let me quickly give you an overview of what this kind of looks like internally. So this is a quick view of our Backstage or internal developer portal. And if you click the bottom right-hand side icon, that's going to give you a chat window like this. And it'll basically, now you can interact with the agentic system. And if you ask what it can do, it's going to reply saying, I can handle a lot of different things, from your dev and research elements to setting up your CI, setting your CD pipelines, other things like, hey, I need the LLM key, I need a development machine, I need a Kubernetes cluster, I need to access to something, I need to go troubleshoot something, I'm trying to find information about something and I want to ask a question, like FAQs type of things, or I'm trying to kind of like correlate different data and I'm trying to build some insights. So it's very capable in terms of what we have been able to employ it for. And this is across the entire development, CI, CD lifecycle, and a lot of functionality around it. Now, on the open source project, the vision is really to do this with the community, for the community, staying with the cloud native ethos, because all of these modern SaaS problems and workplace productivity things, these are every enterprise and every, it doesn't matter whether you're a large scale enterprise or not, everybody face certain level of problems, and being able to share these things and learn and evolve together is a beneficial thing. So do check out the projects. It's caipe.io. You'll have docs and GitHub, etc. At a high level, how does this look like? So it's so you can have the developer and other personas on the left-hand side. You could interact with the agentic system through many interfaces. So it's all standardized with A2A. So you can, we use WebEx for internal communication. So you can access it through your instant messaging. The portal I showed you was the internal developer portal on Backstage. You could assign the system JIRAs, go back and forth on that. And the agentic systems are very good at that, because if the information is not complete, it'll go between the user back and forth in order to make it complete. And then you have also more developer-friendly access through things like VS Code and command line. Now, in terms of the functionality, like I mentioned, there are a lot of functionality around knowledge bases. So things like documentation, so things you have on playbooks or docs or anything like that, that's been fed and RAG is performed. Any live tool calling, so things like accessing a Kubernetes cluster and finding information, PagerDuty to find out who's on call, Argo CD to figure out what's the state of the deployment pipelines, or Git for PRs or other GitHub Actions related things. And then we've also been very successful using GraphRag. So this is where in a lot of the cases you have separate information sources that are fragmented. So by putting all of the important things in a graph database and then being able to do the relationships around it, you are able to make a lot of insights automatically. And in fact, the open source project has a pattern around that, including the RAG piece, the GraphRag piece, and things like agents for doing automatic relationships between the data that is being ingested. And then things like self-service. So if you think about it, the holy grail of platform engineering used to be to get to a form that the user can fill and click a button. You should still do that and strive to do it. But what Agentic can really add and enable is making sure that the user gets to the right form. And when there's kind of going back and forth to fill the right values, making that clarity and understanding the user's needs, and making sure that the form is filled properly and that actual request is done properly, an agentic system can do wonders. So that's where it's a game changer. It's not so much that you're not doing all the good platform engineering work that you have done. It's about do all of that, but then use Agentic to elevate that capability. Now, in terms of what we have been able to accomplish with this, we are not a very big team. It's about 10 of us in the SRE type of functionality. We used to have 3 engineers dedicated for a support desk for all the things that was going. We've been able to use that instead on the support activities. We are mostly leveraging it to do innovative work and creative work, getting the agentic systems to handle most of the toil and operational work. Then things like query responses. It used to take hours for somebody to notice somebody has asked a question. So those type of things can happen within seconds because you have a agentic assistant at your fingertips. Because people don't usually go through FAQs, right? They would ask most of the time, even if you have the documentation. And then certain tasks like, hey, I need an LLM key, I need a development machine, I need access to something, I need a new repository with the pipeline set up. Those type of things are end-to-end automated. So which used to take half a day or a couple of days are done end-to-end within minutes. And then where Kubernetes piece really comes in is where you leverage these type of troubleshooting capabilities. You can get up to 80% reduction in mean time to recover, because most of the time the challenge is it's about finding that needle in the haystack. And these agentic systems are really good at finding that information quickly. So, when you get woken up at 3 a.m., if you can get an event-driven agentic system to go and do the investigation and have a summary and telling you what's happened, that mean time to recover, detect, you cut it, and then mean time to root cause the problem and recover, you can really improve that time. So moving on. Back in February this year, we had this type of a sandbox experience at the incubation unit. So you as a developer, you can prompt saying, hey, build this app for me, push this to my sandbox, generate the configuration for it, and then deploy it. Then obviously, if it has failed for something, like if you don't get the ports right, or if you don't do the resource allocation properly, or something else, you have a bug or something, you'll have to go and troubleshoot it typically directly. So you'll go and check it on Komodor UI. You'll troubleshoot with Klaudia, which was, we were one of the first users of Klaudia when it was released. So that this is kind of the experience you had. Now, Arthur will explain more. So what we have kind of done is, from a developer point of view, you still give high-level prompts on, hey, build me this app, push it to sandbox, generate the configuration for it, and deploy it. And I want a successful deployment. Now, what's interesting is when you hand it over to the system, it'll obviously attempt it, but then it also has access and ability to talk to other intelligent systems like Klaudia. So if the deployment failed for some reason, it would do something like, hey, deployment was successful, but this namespace, this pods are starting, but they are not staying in running. It goes into a crash loop back off. Can you investigate and suggest what should be fixed? I have paraphrased what it says, because typically agents will put a lot more context into the prompts that are being used in order to kind of like make the answer more correct. Then you have obviously, and there's a sub-agent implemented as a part of the CAIPE effort, which would talk to Klaudia and would be able to troubleshoot that. Now I'm going to hand over to Arthur. He's going to explain how some of that piece is done, which is the today's talk, and then we'll go into more details.
Sure. Sounds good. Thanks, Hasith. Am I able to share my screen? Let me just get my screen sharing. Cool. So yeah, this is a kind of live demo of CAIPE. So something we often do as SREs is kind of interact with Argo CD and kind of get our deployments sorted if they're failing. So I can ask, show my CAIPE apps in Argo CD and derive the service names, debug with Komodor if any are failing. So CAIPE is a deep agent, which means that it can do sort of more longer horizon tasks involving planning. You can see at the top, it's actually started streaming the requests for CAIPE because we have 3 deployments across our environments. And yeah, and because it's a multi-agent system, it can call these different agents in sequence, starting with Argo CD. And then once it has the information, it can go to Komodor and Klaudia to debug. So this involves several agents, so it might take a bit of time. But yeah, so we also have kind of other agents like PagerDuty and Jira. So often, you might ask, okay, who's their SRE on call? Can we get their tickets? And then, yeah, sort of Komodor can help with some of the troubleshooting, I think, especially, yeah, for more complex scenarios. So in the streaming, we can see that it's done some analysis. Once the agent actually responds fully, we should get a nicely formatted response. So we're on the final step now, synthesizing the findings. We're also using streaming. So the sub-agent tools you can see when they're being kind of activated on the sub agent. So what we can see here is we found 3 applications for CAIPE. They're healthy, but one of them is has some issues. So if I look at the dev environment, which are typical of dev, there's always some issue there. But we can see that some of the containers aren't ready, and it's kind of information from Komodor as well. So how we were able to kind of implement this was through the Komodor API. So helpfully, Komodor has an open API spec. And what we've done is we've kind of automated the generation of this agent because the open API spec has a lot of information, and agents have come a long way since the initial days where they can reason with kind of a lot more tools. So what we've done is we've written this OpenAPI MCP Cogent tool. It processes the OpenAPI spec, generates an MCP server, and it can also generate an agent. So so what we did is from the OpenAPI spec of Komodor, we generated the agent. And as part of this, we also, so for example, you can ask about like go to the Komodor UI from the chat. So this is something we also implemented. So this is really helpful if you run into an issue and you want to explore more in the UI. And then we've also done evals and benchmarking. So one thing that we introduced is kind of creating a data set. So for Komodor, in order to benchmark this agent, we were able to kind of do some test queries and make sure that they get added to like a test data set. We can see here I've done some evaluation runs for Komodor. I made some tweaks just to ensure that the accuracy is increasing over time. I had like 21 test cases at one point because I was comprehensively just ensuring that all aspects of the Komodor API are possible like by this agent. And we're using Langfuse for the evaluation. So I guess the key here is that we built a golden data set with the kind of queries we expect from the agent, and then we're able to run the evaluation. And this is an example of how we evaluated it. So you can give some kind of general knowledge like, oh, okay, we want to use this cluster for evaluation. And then you can kind of go through each tool individually and give expected prompts and what the response should be. So that's kind of how we built the data set. We also did a Slim integration, which is secure low latency messaging. So that just ensures that if your agent's running, so say you have an enterprise agent and maybe your Komodor agent is running somewhere else, like closer to the clusters, and you want to ensure that you have kind of higher, like improved security on individual kind of conversations instead of just HTTPS. You want kind of a better encryption, then you can use this Slim protocol, which is also developed by agency. And we also implemented that through with the Komodor agent. So it's been a really amazing kind of tool to do a lot of this exploration and investigation with, and that we're using as well for debugging. But I guess my final points are probably around the architecture of CAIPE. So if you're interested, the way it works is we have a supervisor agent, that's a deep agent, and we have these sub agents. One of them is Komodor with MCP and tools, and there's also a reflection agent. So that's quite useful if we want to make sure that the whole task is complete. And recently, I think a few months ago now, we migrated to deep agents. So this is kind of where the planning comes in, and that's kind of the direction we're going in. But I think
Yes,
I'll. to Hasith, or
On that note, we have a question from the audience. Venkata is asking what tech stack was used to build this multi-agentic AI system.
sure. Yeah, so I can go to the repo, maybe platform engineering.
I can, while Arthur is pulling it, so CAIPE as a project, you can run it as a distributed multi-agent system and or a monolithic approach as well. Now, important thing is, things are abstracted into A2A and MCP, so you can use different frameworks. We have used a lot of LangGraph in a lot of places because that was how the initial version was built. There are some examples with strands as well. But it doesn't matter which framework you write something, as long as you kind of abstract it to either A2A or MCP if you're trying to do like tool calling type of thing. Yeah. And Arthur, please add, yeah.
Yeah, and yeah, like the structure is I think fairly straightforward. We have kind of our agents and our multi-agents, as well as kind of knowledge base, and you can see here there's a lot of these are all the sub-agents, so it's quite easy just to add one here for a particular function. And we also have kind of a common library to help you write your agents. And then there's also this generator tool where if you have some functionality that's not implemented yet, you can take the OpenAPI spec and generate an agent. And there's some example code as well on how to do this. Yeah, I mean, we use Komodor as well for the like in the blog, but you can also use other OpenAPI specs. But yeah, I'd say the main thing is the kind of A2A integration because we're a distributed system. But yeah, we also support kind of adding your agent as a regular, yeah, just over like in LangGraph, I'd say that's like if you're just adding it, but if it's distributed, then it can be any framework. Yeah.
I hope that answers Venkata's question. Is there anything else you wanted to show, Arthur? Because I have a couple of questions myself.
No, I think that's on my side.
So, Hasith, you mentioned a burnt out SRE team when you joined Outshift. So, how has that changed for the SRE team? How is their life different now?
So that's I think changed pretty dramatically. I mean, most of it like boils down to like good platform engineering. Like, so we had like I'm not even joking, right? Like there was like 5 different. We are an incubation team, 5 different ways of doing Kafka, right? That's a message bus. You don't need that, right? You need like a good pattern, but you should not be spending your innovation cycles on trying to do things around message buses. We had poor man's way of like AWS accounts. So it's just like I think when I started there was like let me say like there was more AWS accounts than the number of like engineers in the wider organization. So this is like literally in a couple of hundreds, right? So that type of situation. We've come back down to I think like under 11 accounts right now with like 3 main accounts. And that's these are patterns, but you have to like really think about it, right? It's like just because you can do it doesn't mean you should, right? You need to have more than one, but it's not like 200, right? So and then there was a similar approach. We had a lot of Kubernetes clusters without a huge amount of sharing. Partly because people were trying to do things and didn't want to step in each other. So those type of things have changed. So these are like technical things. Otherwise, I mean certainly how the team operates. So a lot of functional things, and then agentic and AI piece really enables us further, right? So that's where how this is kind of like playing out.
And you also mentioned the growing complexity of Kubernetes. You have, as you mentioned, a lot of clusters on EKS, but also edge clusters. And firstly, what's, if you can name like a ballpark estimation of the scale of your Kubernetes infrastructure, and then how would you say that Komodor or Klaudia helped simplify it for the wider team?
So the interesting thing was like when I started, there was a lot more clusters. So we've actually like brought the number considerably down. Yeah, but we still have couple tens of clusters, but we are kind of like consciously keeping it down because it's a cost, right? Just because even if you have the automation and things working, it's another thing that goes wrong. So main thing with Klaudia is and Komodor is really the visual aspect. You know where your clusters are. It's easy for people to log in, and you also kind of like get the access and other pieces kind of streamlined across the setup, so you can have very good story around how RBAC and access management is done. And then when it comes to troubleshooting aspects, people are able to self-service those things. And then that's for the developer persona. But then when you're looking at the SRE and the operation persona, like a lot of the teams, they don't really keep Kubernetes up to date. When you like scale really high, people find it hard to do. So certainly, it helps us, be nimble with that. We've been very good at that. So with less, clusters and, making sure that, the operational things, happen. So that it's really helpful in that point of view. Yeah.
And what gave you the confidence to implement Klaudia? I know Arthur mentioned a lot of the validation steps and the LLMs and the judge component in there as well. But if you had to name a few key things that said, okay, I can run this in production and this can be something useful for me and not dangerous.
I think the main thing for us was like, it's almost like being in the incubator, you have a bit more of a risk, risk of you're more, we can take risks to some degree. Mm-hmm. So that was one part. And then we also knew in terms of, there was no other way out, right? It's not like the modern platforms are getting simpler. I mean, even in fact, like, some of the consolidation efforts, they were not small. They were very difficult to pull off in terms of, in order to simplify the problem. So these type of things, we had to come up with creative and innovative ways to, even if they're a bit risky, to kind of, to get those advantages. So, and more we have done that, we were kind of like, the confidence built iteratively. So it's actually, so if you look at 2024, we started very small. The efforts were, separate. It wasn't like this grand vision, but then everything kind of like, fit into place. And then you kind of like, when you get success and when, some failures, some success, you can then build on it and then you can take more risk with it. So for example, I think, let's take Arthur's perspective. I don't think he had any doubts when he approached it, but go ahead.
No, yeah, it was, I think once I started using Klaudia through the agent, I realized how kind of naturally like CAIPE and Klaudia could, I guess, collaborate to solve a problem. Like because the response from Claudia's text and like CAIPE knows, oh, okay, this is the information you need. You can trigger the RCA and then go back and forth. So yeah, I think it worked quite well, and it helped that the API was documented because the LLM does need to know like what it's doing. But no, that's good.
So for a developer now, so would you say that the response or the experiences that they're more self-sufficient, they can troubleshoot things on their own, whereas in the past it had to fall on the SREs or your team?
Yeah, I think because we had the sandbox environment set up, and we did workshops on, here's how you deploy a container. This is how you use Klaudia to debug it. And I think had good reviews.
Yeah, and there's two elements there because I think typically, when you're trying to do something here, I'm trying to deploy something. Oh, it's a SRE problem, and I'm going to go like ask people. More engineers you have, you get those type of questions. So that's one. And then so really the agentic interface, it's really helpful there because you almost have given everybody their own SRE that they could ask questions. There's no such thing as a stupid question. They could just bombard, and then it's almost like giving you pointers. Hey, maybe you should try this. Let me help you with that. You just fill this form for me if that's what you're trying to do. So that really makes it a very big game changer, right? So
absolutely. And what in your vision, what's next for CAIPE or for the future of agentic AI or platform engineering?
So the interesting thing is, so a couple of aspects, right? So let's start with the Komodor and the interaction we showed. So they are, it's really the almost like native agent-to-agent collaboration type of things, because what we may end up seeing is that you'd have intelligent systems, not just unidirectional, but then bidirectional talking within their kind of parameters and safeguards. So it's you could almost imagine a future in which if Klaudia is trying to do something, Klaudia could ask, hey, I'm trying to do this, can you there's something funny going on here, can you tell me a bit more about this, right? So you can ask, you can have that type of collaboration. You could have these agents being discovered and things dynamically happening. So I think the collaboration aspects of machines doing things that's super interesting. Now, what we have seen so far is like assistant agents, right? Like, so whether it's coding assistants or even in the kind of examples that we showed, it's primarily your like a human assistant type of thing that's going on, which is good. I think we'll see those type of patterns for years to come, and there is a place for it, right? Now, another thing that we are also seeing is completely autonomous and long-running agents. So it's almost like you delegate a specific objective, or it's like, hey, when this event happened, do this. Those type of activities you're going to have kind of into these autonomous systems. I think we are still, some time away before these all become mainstream. But the interesting thing is there's a lot of, productivity and like to be gained by, doing these patterns. So that's what I'm like most excited is this combination of doing the assistant type of things really well to get you that 10x capability. Because if you do it wrong, you actually you don't realize that gain, right? Because you can create a lot of mediocre code very quickly, and you wipe code, and then many people wipe code, and then projects becomes unsustainable, and then there's a lot of cleanup, right? And or it blows up in some way, right? But how do you realize that actual productivity? And then when you really start delegating into the autonomous systems, you really go beyond. It's like I could almost go and say like it's like 100x, because you have things that are going to be working 24/7 on whatever objectives or things that you're trying to do. So that's going to completely like unlock a lot of possibilities and capabilities.
Yeah. This also aligns with Komodor's vision for Klaudia to make it more autonomous and gain confidence with customers that will allow it to actually be self-healing and act as an extension of the ops teams and not, like you said, just an assistant. So I very much agree that this is the future, or at least what's exciting about it for us. There's another question from Venkata about how do you fine-tune your agents to ensure it works like you expected? What is it, prompt engineering or anything more to it?
There are several things. Maybe Arthur has some really good ones that he's like working on. He can touch on. I'll add a bit more. Go ahead, Arthur. Yeah.
Yeah, sure. So yeah, we do it at all kind of levels of the stack from context engineering. But also our RAG system actually comes in really helpfully because if the agent needs to do a set of tasks, we've got our playbooks in our docs. So the RAG fetches the playbook, puts in the context, and now, okay, the agent knows what it needs to do to say like debug an application. At the same time, we're leveraging LangGraph in a kind of more deterministic way. So we've implemented this concept of task config. So what that means is if you have a known process, you can encode this in a set of steps that the LLM is guaranteed to follow. So that's quite useful. It sounds similar to playbooks, but we're kind of doing it in an encoded format to give the LLM guarantees. And there's also exploration in kind of neurosymbolic AI where we're using approaches in symbolic AI to see whether we can get our deep agents to learn patterns from data and then encode that in a way that can be executed like reliably. But yeah, it's a lot of work in that area. Yeah.
Yeah, and touching on a couple of other things is it's like garbage in, garbage out. That's true, right? You know, if you just point everything at a ton of outdated wikis and all sorts of things, you're not going to get a good outcome. And in fact, when we initially did the docs, we had an effort to kind of like redo some of the docs. So it's just like less, more quality is better than a lot of just pointing it out to a lot of outdated things. So that, you know, that and this is important, right? You know, if you sort of, you know, that curation role to make sure that the data is good could be agent assisted, but that's an important aspect. I mean, this even applies even in kind of like doing graph relationships type of thing. So like if you are doing it at a very large scale and very complicated, you may want to consider, you know, having oversight and thinking about those aspects beyond, you know, just simple automation and things. Then other things are just like Arthur mentioned, obviously you have the generative models and techniques there you can do, like the type of the model that you use, like the reasoning models, so more complex things, figure out how you do the context, then use smaller models that'll end up being you know, cheaper, faster, more accurate for the you know, when the problem is, you know, more defined what you're trying to do. Was it, you know, something very general purpose that's gonna, you know, have more hallucination probability, right? And then the point is, you know, it's not about just Gen AI, right? There's a lot of other disciplines in machine learning. So things like symbolic AI could be used hand in hand in order to create better systems.
Yeah, just one thing I'd add is also evaluations. I think that's one of the biggest tools in the toolbook. And yeah, LangFuse, Langsmith, they're both software we've used, and yeah, they work fairly well.
Another question for you both is, how do you show the value internally of the platform you've built? How do you display that it was actually worth the effort and time and money invested into it?
So from our side, it wasn't. It was clear, but you know, this wasn't like funded separately. So we had to find time and time to do it. So it wasn't like, you know, somebody went and wrote ourselves a check, right? So we are kind of like in a incubation, but we are trying to serve a lot of things, and it's like too busy to kind of like even think about innovation. How do we get ourselves out of it, right? So that was really our kind of motivation to pursue this. Now, when you, you know, if you start small and show success, then you are able to kind of get that buy-in and opportunity. I think, you know, particularly with how things are kind of evolving and how fast things can change, I think the main thing is, you know, start small, show actually show value and do something, and then kind of iterate from that. Obviously, it'll help getting the right leadership buy-in and other things, and then measure what matters, right? Like don't measure the wrong things because it's very hard depending on the organizational culture and setup. Sometimes you have to before something starts, you have to show how the KPIs are going to work and how the value is going to be created. Especially if you're trying to do something very new and very risky, it's very difficult to do. So almost like that conversation is a non-starter, right? So in some ways, avoid having that conversation. Have some like proof and ammunition before, and then you can even if you need more investment, then you can kind of go and show value. Yeah. Not easy, but yeah.
Oh yeah, nobody said it was easy, and it looks nice on that slide you showed where there's like very clear milestones, but I imagine it was more complicated than that.
Yeah.
Okay, so we are almost at a time. Is there anything you want to say as closing remarks, any summary or things you want to leave the viewers with?
I mean, it was a pleasure talking to all of you guys. I would say the main thing is there's a lot of hype around AI, but there's a lot of transformational properties it has. Important thing is embrace, learn, and kind of navigate, because but whilst these things are capable, they are also very like humans have to work alongside these systems for literally at least the next 2 decades, right? So that's so I think we'll learn a lot of things, and the world will evolve in ways that are so many things are possible, which is, I think, the optimistic side of things, right? So
yeah.
Arthur, anything you want to add?
Sure. No, yeah, I echo that, and also just that these tools in the SRE domain are super helpful, and do get involved either on the open source side or with Komodor, because anything that can help to take the burden off the SRE, I think, is pretty good, really good for organizations. Yeah.
And what would you say to people from organizations similar to Cisco in scale or complexity of their infrastructure? What would you say to those who are evaluating an AI SRE solution? We know it's very buzzworthy right now, so maybe they're considering Komodor and Klaudia, maybe they're considering other solutions, building in-house, something open source. What would you say the key things to consider are, or why are you using Komodor and not something else?
Yeah, I can answer the Komodor side first, because I think the quality of the tool matters. And for example, I can go out and find 100 MCP servers that say they do something, but then when you actually try to use them, it doesn't work. Whereas with Komodor, it works reliably. And I'd say advice in the more general sense is keep things like use an open source framework, like, I don't know, we use LangChain or Deep Agents or CAIPE, because it means that you have the flexibility of choosing the things that work for you. Yeah.
Sid, you're muted.
Sorry, I couldn't find the button. So one thing I would say is, like, when you decide build versus buy, I mean, the main thing is doing a proof of concept and getting to, once you get good at some of this, getting to accuracy about 60 to 80 is not too bad when you have people who know what they're doing. But the thing is, like, getting from 80 to 95 or 97, 99, that's hard, right? And making sure that you get like all the evaluation and all these aspects of these probabilistic systems are quite hard. So that's when I think the buy option makes a lot of sense, right? If you can spend the money, like leaving all the other aspects aside, like that's a challenge, right? So the going from a POC and something that you can do for certain accuracy to very, very good functioning, it's effort, right? So you need to be prepared to and have a strategy to do it if you're trying to like do it on your own. So this is where like the buy makes sense, and also in cases, and then if there are opportunities to do it together, the community aspect makes sense as well, because you can kind of like learn together and like kind of try to do the right things or patterns that work together, right? So
that's good. So I think we'll end on that note. And so thank you so much for joining us. Thanks everyone who is watching us live or watching the recording. As I said at the beginning, we'll share the deck and the recording with everyone. And feel free to reach out to Hasith and Arthur on LinkedIn, right? Or do you have any other places where people can find you that you want to share?
No, LinkedIn is perfect.
Yeah, cool. Sure, CNCF Slack also works. Whoever's there. So thank you both again so much, and till next time. Bye now.
Thank you. Bye.
Thank you. Bye.